I guess this is my mic, so I can use my mic like this and then hold it up to the other person. Like, does it make a lot of difference how far away it is from my mouth? Oh, you've gone live. Okay, good.
Well, I thought you were ready. I don't think it matters. Just hold it away from yourself. Is that what you're doing right now?
I don't know. Over here. If it's over here.
Yeah, I can still hear you.
That's crazy.
Okay, so we're broadcasting the room right now, and we're recording the audio from everything. Okay, I think we're reasonably well set.
Okay, I'm just trying to get used to using my right hand to do something complicated. There I am.
All right, let me talk us in.
All right, man.
Hello, dearies. Welcome to Undersampled Radio, episode 80. We have a special episode for you today. We're joined by the gang in Copenhagen. Hey, Matt.
Hey, how's it going?
Good. What's happening over there?
I'm starting to realize the folly of holding my phone up like this with one hand. That's the shake. I don't have the strength. Yeah, so I'm here in Copenhagen. We're at the Rainmaking Loft, which is a really awesome co-working space. This is actually just the third floor, so right up in the roof. You might get an idea from the bright sunshine outside and the fact that every single window is open that it's incredibly warm here at the moment, and we're all kind of sweating. There's no air conditioning.
Do you have any big servers fired up, spinning a whole bunch of fans and making heat?
Well, I don't know. There's 50 laptops in here. That's probably doing a bit for the heat load in the room. But no, David from Dell did not bring his C4140 or whatever it is this time. But he did bring 15 laptops and 2 awesome Meta headsets, 2 HTC Vive headsets, and yeah, we've got all sorts of other gadgets on the go. I'll maybe take you and show you a couple of things in a minute.
Yeah, cool. Is that Brendan in the background, I see?
What's that?
Is that Brendan in the background?
No, actually, no, Brendan couldn't make it in the end, unfortunately.
There's somebody over there over your shoulder that looks a lot like Brendan in this low-res video.
Probably another haul. Am I low-res?
Well,
really?
No, just medium-res.
Okay. Yeah, no, so we've got, I think, 63 hackers at this event, which I think is actually the exact same number that we had in Paris. We've got 12 teams on the go. Again, I think that's about what we had in Paris. And yeah, we're in this beautiful space. All the teams are up and running. We actually got started last night on Friday evening. So the teams got formed then, and they're all into it right now.
Awesome. Yeah. Can we meet some of the teams?
Yeah, we can. In fact, what I might do is let's go meet Miguel if he's here. Yeah, here he is. Okay, so I don't know if you can see this team here. Several of them are from Aachen, and they work on the GemPi project. This is Simon here that you can see there, and if I kind of if I come up here, I don't know if you can see the contraption they've got in the background.
Oh yeah, what is that thing?
This thing? Yeah, so this is a projector with a Kinect, and there's a box of sand underneath. So they and another team, and actually I think 2 other teams, are playing with this kind of, what would you call it? Sort of, it's a kind of augmented reality, but with this physical aspect to it, where you can actually touch the sand and change how you're interacting with a subsurface model. It's pretty cool. So I was going to chat with Miguel here. Miguel, would you join me out here so we can chat for a sec? Yeah, I'm going to try and do this being a cameraman and talk to you. And you don't
so it's not only a podcast, there is also video.
You can put that in your ear if you want. Certainly my ears are quite clean. And hopefully he can hear you. So,
hi,
Miguel Zavaga. Who are you and where did you come from?
So I'm Miguel. I'm doing a PhD in Aachen, in the RUTH, with Florian, actually. Florian Bellman, let's specify so people can look it in Google. And yes, I've been a couple of years in doing my PhD, and it's basically GenPy, that is a open source tool to create implicit geological models like Leapfrog or GeoModeler and so. And since the beginning is built especially for uncertainty analysis, now it's growing in many directions because there are many people starting to use it. But the original idea was for probabilistic programming.
Okay. So is GenPy completely written in Python?
It's written in Python, but the core is using Theano, that is a library for automatic differentiation made by the guys of the University of Montreal. And then that part is compiled in C++ or in CUDA. So for the heavy lifting is using optimized code.
Okay. That's a pretty cool project. Now, can you clear something up for me? Because I've heard of GenPy and I've heard of
Pinody, yes.
What is the relationship? Is there a relationship between these?
So my professor basically is the relationship. So Pinody was made, well, actually Nody is an independent software that it was made by Mark Jussel in the 80s. And that was for kinematic modeling. So you start from graphic model, and then you start make events like folding. So you are reconstructing the history of the model.
Right.
On top of that, my professor Florian made the wrapper of Python. So it's basically to be able to manipulate these models and the history from Python.
Right.
And they have been used for making synthetic models and so.
Gotcha.
GenPy is completely independent on that aspect. So GenPy was built from scratch since 2 years ago.
Okay.
And it's based in the work of Lajuni, that is basically the same mathematical algorithm that is used for GeoModeler, that is a commercial package. And we started to building it, but it's quite independent. Actually, we have a wrapper to connect Pinody and GenPy, so you can extract points from Pinody to generate the models in GenPy, but in principle they're independent. And the way of constructing the model are also independent. GenPy is an interpolation, so you don't reconstruct the history. In Pinody, you really have to go always from the flat model to whatever point in history that you want to recreate.
Okay, gotcha. Cool. So, and you guys are using GenPy?
This is GenPy, yes.
Yeah.
Yes, because the advantage of GenPy is because it's written in Theano, it's pretty fast. So basically for every update of the Kinect, we are really recreating the 3D model and interrogating in. So the good thing of this is that you can really interrogate anywhere in the space. It's a continuous interpolator.
Right.
So we are just looking where are the points of the surface, and we ask GenPy what is the lithology in those points.
Yeah. Okay.
But you can ask anywhere.
I see.
And that is done almost in real time. Takes a bunch of seconds or milliseconds, sorry, and that's why we can just move the sun and recreate the model. And one thing that we will show tomorrow is that we can also change the underlying model and see how it's changing. So not only the topography, we can also change the 3D model.
Yeah, yeah. Okay,
cool.
Awesome. Very cool. Well, it's a pretty exciting project. So yeah, good luck with it.
Thank you.
And thanks for talking to us.
Yeah, my pleasure.
Really nice to meet you.
Yeah, me too.
We'll get these guys back sometime to talk about their project.
Yeah, sure.
In a bit more detail, I think. Yeah. Thank you. Yeah.
Matt, you need to go stick your phone inside of that sandbox.
Why?
So we can see what it looks like.
Oh, you want to see it in a bit more detail?
Yeah, and you have this handheld camera, so we can really get up close and personal.
Oh, I see. Yeah. Okay. Well, there'll be. Oh, sorry. There's my thumb. There'll be. So we'll be trying to capture some of the projects when they're kind of up and running. They have Sandbox working right now, but we'll definitely try and get some of that stuff online. Certainly be on the blog, of course, but maybe we can get a summary of the presentations tomorrow to put on the Undersampled radio channel too.
Okay.
Okay. I should walk the other way. I've moved into a different room now, so maybe I'll just flip the camera around a sec. So I came through from the other side, and now we're in the second space, which is just like the first space, in fact, a little bit cooler. They've been serving us fantastic food here. One of the really nice things about this venue has been that they've got a couple of staff who've been here the whole time, basically supporting us, and they've done all the catering, taken a bunch of my workload away, which has been really, really nice. So yeah, we'll definitely use this place again if we ever do anything in Copenhagen.
Fantastic. seem to have lost your video feed, Matt, if you can hear us.
All right. Yeah, I see that.
Let's see. Oh, okay. We got you again.
Oh, okay, cool. So these guys behind me are working on some RGB displays and sort of forward modeling, I think, spectral decomposition from wells. That's the overview. But one of them is Steve Purvis. You might be able to see at the back there. So I was going to pick on him, and we'll get the lowdown on what these folks are up to.
Cool.
And poor Steve is a bit discombobulated today because he was like a day late, essentially, he had just had a travel nightmare. So I'm going to go pick on him now. Hey, Steve. Sorry, he's actually busy, but I'm going to pick on him anyway. Yeah, come and tell us about your project.
And maybe when you guys talk, you could step a bit closer to the router or something. It's we're dropping you. So Matt, if you can hear us, we're losing your signal.
Oh,
come on.
We still have
no, he's back
by the laptop.
Okay, cool. Hey, man.
Hey, Steve.
Cool.
How's it going?
Hello. Yeah, good.
Good to see you.
It's all going in different directions.
Yeah, that's right.
Yeah, so our project's about RGB, or exploring RGB blends. So the initial bit was, can we get beyond, and can we relate it to well data in some different way than just forward modeling a wedge?
Right, okay.
So what we decided, we thought of lots of things. Some guys are trying to scale stuff in the cloud. We're talking about scale spaces and upscaling wells and things like that. But the aim is to produce a colored well. So what we have is we've chosen just a sort of CWT approach. We're doing that on the seismic and on the well logs.
Mm-hmm.
And we're trying to produce colored wells so that we have an RGB blend beside the well alongside the seismic.
So it's like...
So we've got AI logs.
Okay.
Which
acoustic impedance logs, not artificial intelligence.
Yeah, exactly. And we're either upscaling those or we're computing with different wavelets. We were just talking about that now.
Okay.
But the idea is we'll be able to get different frequency synthetics for a well, and then we'll have, we've just computed a huge 4D CWT cube with a whole bunch of frequencies.
Okay.
Cool.
And then we're just trying to get something so we can start picking different RGB blends and having the well, see if the well and the seismic line up.
Do you think, will there be any aspect of trying to make some of the decisions about which frequencies you use automatically and being adaptive like that?
Some of the guys, especially Thomas from Total, he was really keen on trying to do an optimization algorithm. There's time for that. Yeah. Which now we have. We basically have a CWT expansion per trace in this big NumPy cube. So let's see what he can do with that.
So how long did it take to compute that big cube? Is it
a minute on my Mac? It doesn't take long.
Okay.
The cube's only 150 meg.
Yeah. Okay.
Once you expand it, then it's about a gig.
Right. Okay.
And you could do that all on the fly, but it's just easier just now, just to compute a lot.
How did you decide? Right. How did you decide how many cubes to generate? How many decompositions to do?
We've just gone overkill. So everything from 3 hertz, which of course we can image, we can get back. No, everything from 3 hertz up to 80, it steps to 2.
Okay.
So through the kitchen sink at it, because we want to get that loaded
sure.
into a little Flask server and try and show some results on the web.
Sweet. Sounds good.
Pretty awesome. Well, you can get back to your team. Thanks a lot, Steve.
Good to see you.
Yeah, cheers. Right. So anyway, there's a couple of projects. Like Steve just like rolls straight back into it. Eh? I was expecting him to be all flustered, and actually he's fine. Hopefully you can hear me now.
Yes, I can.
Yeah. So I'm going to wander back a little table. I'm probably jumping around on Wi-Fi. That's part of the problem.
Yep. So we'll switch over to the laptop view when Matt sits down, because we've lost him again. Sounds like everyone's having fun over there in Copenhagen. I hope we get to see some of the toys that David and Dell brought along. Maybe we can get
David.
run over there.
Yeah, he's. That's a really good question. Where has he gone? Well, you know, we started serving beers downstairs at 5. Oh no, he's over there. Here, let's go and chat to him. Hang on, I'll walk straight past. He's in his VR cave.
Oh, sweet.
There he is. There's David. Chatting to Graham.
Hey Graham, how you doing?
Hey man.
I'll use this as a mic.
Okay.
What are you up to?
Well, we bought different toys to this hackathon. We bought virtual reality and augmented reality stuff, so we've got that all set up. We've got a team who's trying to integrate augmented reality with a sandbox to do kinesthetic seismic interpretation in sand.
That's actually another one we talked to. Yeah, it's all crazy up here.
What is he working on over there? I assume he can't hear me.
Who?
David.
I can't hear what Graham's saying, of course.
Sorry. Yeah, that's right. David can't hear you.
What is he working on over there?
Are you working on something or supporting anybody?
I'm helping out a couple of different teams with random bits of hacking, my usual infrastructure-y, gluing stuff together, finding data, and reminding people what coordinate reference systems are and why they're important.
Cool.
Yeah, David is now or will be by this time tomorrow, one of Dell's AR VR experts.
Nice. Cool. Can we see the VR setup they have over there?
Can we see the VR setup? Well, so it's, I think, consists of this computer.
Yeah.
This headset.
Is that an Oculus? Oh, yeah.
It's an HTC Vive.
Yeah.
And it has these sort of table tennis bats that go with it.
Mm-hmm.
And then these corner point reference systems of some kind.
Do you know
microwave interferometers.
Do a demo of the augmented reality.
David's saying that the AR is easier to demo. I'll show you the AR headset because it's pretty cool looking. Oh, so what we can see what you can see then, David?
Exactly.
So David's going to just.
What is that? A HoloLens?
It is a bit. It's the same kind of idea as a HoloLens, I believe. It's called Meta. It's obviously much cooler than a HoloLens.
You can tell David that he looks rather dashing in that crazy headset.
Eerie.
Oh, that's brilliant. A live demo, and of course it went on.
It's quite eerie looking at him because, of course, he's not looking at you even when he's looking at you.
Can you see the AR projection on the screen of the computer?
Brilliant.
No, I can't. But he's actually hasn't got anything, I don't think, displaying right now. So it's basically got a little screen up there, pointing downwards, and then I guess the glass is at just the right angle to project into his eyes. And then on the outside, there are sensors all around the front of that helmet. So the idea with Meta is that you can reach out with your hand and interact with the objects in your AR space. So you don't need paddles and whatnot.
That's right. You use your hands to interact with things.
So you can
see in front of you.
Can you? Are you actually looking at something now? Or are you just enacting this for us?
No, I'm actually. So curiously, I'm interacting with virtual. Sadly, you can't actually see it. What I'm able to do is pick objects up, and I can rotate them, zoom in. So the shape that I'm manipulating. This would be so much more effective if you could actually see what I could see through the.
What can you see? I'm imagining you dressing a lobster or something like that. It looked like quite an elaborate dance.
What's interesting about it is it's very intuitive. So whereas with you're doing a whole bunch of different gestures, to be able to interact with stuff, and they don't bear any relation to what you see. With the Meta headset, you have a wider field of view, so you can see more stuff left and right. But if you want to pick up an object, you just reach out, wait for it to be highlighted, squeeze your fingers, pick it up, move it, and drag it around.
Reach out and grab it?
Yeah.
How you do it?
All right. So it's pretty bananas. I'm going to leave you to it, David. Thank you for the little tour. Good luck. I really hope that some of those AR projects are, because it looks really cool. And we weren't able to see it just then, but I think normally you're able to actually see what the person wearing the headset can see on the screen of the computer. So it's a bit more.
He must have switched Wi-Fi networks again. Let me see if I can switch it to the laptop. Matt, if you can hear us, we still can't hear you quite yet. Your laptop is muted. There you go.
I'm doing a dance.
Okay.
To switch back.
Okay.
Ta-da.
Hello.
So smooth.
Oh, now the video is nice and crisp. Cool. Well, it looks like people are working on some wild stuff.
Yeah, we've got, like, I don't know, ISO certainty surfaces and mapping, forward modeling. I guess, yeah, so some people are using the sandbox to make forward models using the surface of the sand, and then modeling the wave field in DeVito and projecting the wave field back onto the surface of the sand.
That's cool.
Yeah, it's going to look so awesome if it actually works in real time. And then the idea is that there's some little Lego pieces on the surface of the sand that represent the source, and you can move those around and check and see the wave field change.
That is nuts.
Yeah.
Okay, that's cool.
So yeah, the Connect thing, right, can see depth, but it can also see color, like it's a camera.
Oh, I see. It's only the connecting, so it's got the stereoscopic view.
I guess that's how it does the depth. Maybe it's IR. I'm not sure actually, but yeah. Anyway, it's got multiple sensors, so you can actually do quite a bit with it. Oh, Lucas Mosser and Jesper are back together. Not that they were apart, you understand.
Trouble.
The dream team is back together, and they are working on. I figured you'd want to know what they're working on.
Yep.
They're working on dimensionality reduction of geoscience data, and particularly, I think, embeddings. So Tisney type technology, and I think obviously that's sort of a solved problem, but it's like, can we learn things about information content of these spaces? Can we learn things that are interesting to interpreters by visualizing these very high dimensional data sets in 2 or 3 dimensions?
Mm-hmm.
There's half a dozen other teams working on all sorts of stuff, from visualizing big grids to looking for, how do they call it, blind spots in their data. So like when you walk into a big data set, it's like, what kind of coverage do I have? So trying to visualize where the gaps are in your spatial knowledge,
mm-hmm.
And what kind of uncertainty that might lead to.
Cool.
Yeah.
Cool. Well, thanks for the tour.
Thanks for checking in.
Stuff to do, so I won't keep you too long. But we look forward to hearing back. Or maybe are we going to broadcast the presentations?
The jury's out exactly how we're going to capture the presentations. I do like the idea of doing them to live hangouts, because then it records it and we don't have to capture it all. So I think we probably will end up doing that. We'll see how clever I am. I don't think I can be as clever as you. See, that's the problem. So we'll see how clever I can get with devices and stuff. Evan's coming tonight, so I'll have another pair of hands.
You can see I still have tape on my microphone from both Paris and from Salt Lake City.
As mementos, or because you can't get it off?
Oh, sort of a combination of both, actually. Cool. Okay. Well, thank you everyone for joining us on Undersampled Radio, and we'll see you next week somewhere, sometime, somewhere in the world.
Yeah, thanks. Bye.